Welcome, my name is Dr. Dan Wedding, and this is Dr. Wedding, PLC03. Hello World. Hello World is the first program you are taught in every computer language. It is often the easiest task that can be done in the computer language. The purpose of Hello World is to teach the student how to use the software and not how to program. In this version of Hello World, you will write a program that will turn on a lamp when a switch is toggled. You will need to perform 3 steps in order to go from scratch to a working PLC program. Step 1. Open up a new project. Step 2. Write your main routine. Step 3. Download the program into the controller. Step 1 is opening a new project. A project is like a suitcase that holds all of the parts that are needed for your PLC to do its job. This suitcase holds the I/O configuration, data types, controller information, and tasks. The next section will show you how to perform Step 1. Open the RS Logix 5000 Integrated Development Environment by double-clicking the desktop icon. This takes about 30 seconds to load on the lab computer, so it was edited for time. This is the IDE, but it is currently empty. Now you need to open a project. Go to the top and click on the File menu, and then select New. This will bring up a new controller window. If this is your first PLC program, you may want to replace the word controller with the word project in your mind. So you will think of this as the new project window. Start by entering the type of hardware you are using. This is the controller in my lab, but your controller may be different. You must select the software revision from the drop-down menu. I am using 20. You also need to give your project a name. If you enter a space, it will be replaced with an underscore. The description is optional, but many companies have policies governing descriptions and comments. I am going to save my project in the default hard drive location. Finally, I am going to use the default security settings. When I press the OK button, the new project will be created. When the project opens, a docked window will appear on the left side of the screen. This is the controller organizer, but you can think of it as the project organizer. It allows you to navigate through the project. At the top of the window, you should see the name of your project. You should also see the name of your project at the top of the screen on the title bar. At this point, your project does not know where to find the hardware, so the path is set to none. To assign the path, you need to go to the Communications drop-down menu and select Who Active. And yes, the Grammar Police should be issuing a ticket for that window name. Start by expanding the Allen Bradley node, the one that starts with AB. When the section expands, you need to wait until the software eliminates the unused nodes by marking them with a red X. Select the active Ethernet port, and then select the backplane. Before I continue, please notice that the Set Project Path button is grayed out. When the processor is selected, this button will change from dark gray to black. This subtle change is often missed by first-time students. This is the path to the processor. You may notice that the last project name is appended to the end of the processor. This is normal. It's annoying, but normal. When the processor is selected, the Set Project Path button will become active. And pressing this button will set the path to the controller. You can now close the Who's Active window. Once you have a new project, you will need to write your ladder logic program. Your program will monitor and control the field devices as discussed earlier. Your ladder logic program can be opened using the controller organizer. Go to Tasks, Main Task, and expand Main Program, and double-click on Main Routine. This will open up the program that will be loaded into your PLC. To make it easier to read, I am going to hold the Control key and turn my mouse wheel. This will zoom in on the program. I am going to start by adding a comment. Go to the blue section at the start of the rung and click on the right mouse button and select Edit Rung Comment. This will allow you to write a comment about this rung. A comment is a note in the code that is ignored by the computer and the PLC controller. It is information left for the next programmer who will work on the code. Many companies have policies about what is in a comment. It is common to include your name, the date you started the program, and a brief description of the code. You should also include the dates and a description of all major revisions. When you press the green check mark, the comment will be saved and you will go back to the program. Now I am going to add my first command. This programming language uses images instead of commands. Start by clicking on the XIC command to add it to the rung. This command needs to be assigned to one of the physical inputs. This connection is called a tag. On the command, right-click the mouse and select New Tag. This will bring up the tag editor. Start by giving the command a name. If you have programmed in other languages, this is like naming your variable. Next, you need to pick the type this command will be. For this example, we will make this an alias. And finally, we have to assign it a value. Under the Alias For drop-down menu, you will see a list of input and output connection points. These points start with local because they are attached to this controller. The number represents the slot where the card is found, and the letter stands for what type of card it is. I stands for input, and the letter O stands for output. We will connect this variable to the local connection point in card slot 1, and it is an input card. That accesses the card. But this card has 16 different inputs. So we have to highlight data and bring down a menu that allows you to pick one of the inputs. We will attach this command to input 0. When you press the Create button, you will see the command on the rung, its name, and point where it is physically connected. The switch is an input, and it will need to control an output. To finish this line of code, I will go back up to the menu and double-click on the OTE command to add it to this rung. OTE stands for Output Energize. It will turn on or off a device connected to the PLC. The OTE command is currently undefined. You can see it is labeled with a question mark. At this point, the rung will not work. I am going to intentionally leave this error in place in order to demonstrate how to check for errors before putting the code in the PLC controller. Go to the menu bar and press the Verify Routine command. If there is an error, it will be displayed in the error window. The error will tell you what rung number, the command that has the error, and what the error is. I can now close the error window and initialize the OTE command. This is done the same way as the input. Start with clicking the right mouse button and selecting New Tag. Give the command a name. The type is alias, and the location is local. Slot 2, and it is an output. The device will be attached to pin 0. Now that all of the information is filled in, press the Create button. Now that the rung is complete, we can recheck the routine. This time, when we press the Verify Routine button, you will see a message at the bottom of the screen telling you there are no errors. Step 3. Download the code. When your program is complete, you will need to move it from the computer into the PLC and test it. Moving the code from the computer to the PLC is called downloading your code. If you take the code that is already in the PLC and move it to the computer, it is called uploading. There are two modes that the IDE can be in. It can be offline, and that is when you are editing the code. Or you can be online, when you are downloading and testing your code. There are two ways to switch between online and offline. You can use the IDE interface, or you can use the physical key on the front of the system. The key is currently in the middle setting marked REM. This allows me to change modes using the IDE. Next to the offline label, there is a drop-down menu. You can go online and then download your code, but this takes 2 steps. But it can be done in just 1 step. If you select Download, the software will automatically bring you online before downloading the code to the PLC. If the download menu option is grayed out, it means the code in the IDE and the code in the PLC are the same, and you don't need to download it. I am going to just use the download button. This will bring me online automatically. This message is warning you that if the PLC is attached to equipment, it may move when you download your code. The buttons and lights are safe. Therefore, I can press the download button. And in just a few seconds, the code on the screen is copied into the PLC. The system is already online, so we can go back to the drop-down menu and switch to run mode. When the system entered run mode, the switch was in the on position, so the lamp immediately turned on. This is what the warning message said would happen. If this was a moving object, instead of a light, someone might have been hurt. You should also notice that when the switch is on, the switch turns green. The lamp also turns green, letting you know it is on. When I throw the toggle switch, the light will go out and the green indicators on the rung will disappear. The system is running as designed, and the information from the panel is also showing up on the rung. Now I am going to take the system offline so I can save the project and close the program. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This will help introduce these videos to other students who might be struggling in their PLC class.